Hi, Alex Thissen. Excited to be back again in St. Petersburg. I'm a cloud architect in the Netherlands for a company called Xspirit. And we do a lot of consulting with companies from startup to big enterprises. We see a lot of things happening there, and that's what I want to talk to you about for the next hour. It's the journey when you start building your new web API and you do file new project and you start building your implementation. And I'm sure everybody of you has their own set of business logic and things you want to put into web APIs. But then you need to go into production and you need to take care of a couple of things. So just file new project is often not enough. There's a lot of things to be taken care of, and I've sampled a few, and that's the topic for today. So we have a lot to talk about. All of these things, it's ambitious for 1 hour, but we'll try to get through them. So throughout the demos that I built, I've been using ASP.NET Core 2.1. It's still in preview, so you can download the latest bits. It's on preview 2 at the moment, and I think that soon it will be coming to a release. You can see an entire list of things that are there that will benefit us building out the things that you need to do to have a proper production-ready web API. I'm not going to discuss them now because we will cover them when we go along. It ranges from security to better forms of creating documentation, all of the good new stuff, and we'll touch upon them as we go along. Well, if you start your journey and building your web API, you need to do a lot of decisions. Think about how you should design your web API. And you can choose a lot of things. You can choose between plain old XML, which is just sending out and receiving XML and working with that. Or if you're aiming for a modern web API, you can actually do a REST-style API. There's all these best practices. There's a lot of debate even on what you should do, what you shouldn't do. Just bear in mind, keep to the semantics of HTTP. So that means meaningful verbs, idempotency, the statelessness of your web API. Microsoft actually has a couple of good guidelines on how they build their web APIs. If you need to choose something, you could have a look at their guidelines because they have them for APIs in general on how you should do REST, how you should version it. And if you're more into Azure and how they build it there, you can have a look at their design guidelines because there's also some form of decisions. It's opinionated, so yeah, it's choices made by Microsoft, and you might choose something differently. It's all up to you, but have a clear set of guidelines on how you want to build your web APIs. Well, with that said, let's drill into the first demo. We'll start off with the level of file, new project, and just really simple stuff, but we'll build on to that afterwards. So what I have is just a really simple ASP.NET Core 2.1 project with an implementation, very small. I like gaming, video gaming, so I used to play a lot of Counter-Strike, the online shooting games. And there's this master server that you can query. And this is just an example of an external web API that you can call. It can be any other thing. If you've been to Christian's talk yesterday, he talked about calling other web APIs in your microservice architecture. He mentioned a few things of what you should keep in mind. We'll cover those. So just think of this as one of the external resources that you could call, and we'll be doing that. So calling the web API, and that's all there is to it. Okay, let's do the demo first. So after file new project, if you do the ASP.NET Core 2.1, you'll find that it's really trimmed down. It's been like that for a longer part. It's still the usual stuff. So inside of your main, if you do self-hosting, you'll create a web host. You do this very small create default builder. We'll take it apart in a moment and see what's actually inside there. And after that, the new startup will call the startup class and look for the methods configure services. And you will find that there's still add MVC, but there's this set compatibility version. where you can indicate if you want to be compatible with 2.1 or 2.0. If it's 2.1, they change some logic on how to deal with input formatters, for example. And if your implementation relies on that being compatible with the old way of doing things, you can just tell it that you want to be compatible with 2.0. Or you can do 2.1 and opt out of certain new stuff individually. So that's one of the new things that you'll encounter. The other thing is that there will be a huge HSTS. I hope we will get to it. Use HTTPS redirection, which is for secure transport. And for the rest, it's almost the same. So now we want to call our Web API. And the Web API, it's, let me zoom in a bit on the URL. It's this steampower.com. It has this endpoint for a particular Web API. It has a method. It's not really REST in a pure sense, but it has some things like limits and an API key. After you call it, you'll get back some JSON response, and this is the external Web API that we want to call. There's not a lot of documentation here, so it is documented, but it's all written documentation, so nothing much to go by. We know about that there's this limit and this key that needs to be added to the query string, and we know that this is the relative endpoint within the base URL, steampower.com. So we'll take this one as an example. Okay, going from there, how would you easily call such a Web API? If you don't know it yet, then you might be interested to see that there's this refit library, refit. Refit allows you to define an interface in C#, which has some attributes to indicate relative URLs. It gives you a function name or a method name where you can insert certain parameters, and those will be translated to query string to the body. You can annotate it with all these attributes just to help you facilitate calling such a Web API, and it will take care of creating the proxy for you. Creating the proxy is done by this call, REST service 4. You give it the interface, you give it a configuration. So here's the Steam base URL that I put in config. It's there. So there's the base URL with the iGamer service. And there's the Steam API key. Don't worry, I'll say that afterwards. Okay, with that, after you've called the REST service 4, you'll get back an object reference of type iSteam client, and you can simply call it. It's all async, so you need to do await and async methods for your call. But this is our get method. And that's about it, what you need to call the API. So we call it here. We pass it a parameter, so that's the Steam API key and the limit. We get back a string, and we pass that as the result in this new thing, action result of T. That's a new in ASENET Core 2.1. Now let's see if this works. Okay, so if we go to, we get so it's actually essentially proxy, but you can do your logic inside once you've called the other Web API. Now we're just passing on the data, but just imagine that you would do smart stuff with this, like these are all addresses of other game servers. You could store them in a database. You could keep track of which servers have been online in a certain amount of time, which players were there, which were the popular servers. So this is where you can add your logic, but that's not the topic of this conversation. So this is how you easily call such a Web API. But I'm sure you see that it's kind of, you can take this to production, but what would you know about it? You give somebody a Web API, it's undocumented, it doesn't take care of versioning, it's relying on things to be available and doesn't take care of what if it's not available. So a lot of things need to be added, and we'll take care of that. And we'll start with the next thing, that's called versioning. Again, your Web API will probably evolve over time. It will go from simple to more mature, more rich implementation, and that's something that you need to take care of. But do remember that if you provide a Web API, you're actually signing a contract with your consumers, and you aren't supposed to break it that easily because you'll destroy all the contracts or the client consuming your Web API. So if you do incompatible changes, and you can discuss of what is incompatible, but removing stuff is usually very incompatible. Adding stuff, you can decide if it's compatible or not. But breaking your contract, you should change your major version or your minor version, depending on how big your change is, perhaps. Some people use the major version as an indication that the previous version will be deprecated anytime soon. So that's an indication that you should move to the next major version to keep up with consuming our web APIs. There's also this principle of least astonishment, because even if you have certain behavior that wasn't really there, people rely on it. So if you change something and it works differently all of a sudden, it's also incompatible. Maybe everything is compatible on a binary level, but just the behavior changing might also require that you up the version number. If everything stays the same, then you can just keep it compatible and you can keep your current version number and just patch it inside. But if you do need new versions, you need to think about the version numbering. Also a debatable topic. Where do you put it? Do you put it in your URL? Do you put it in the query string? Do you do it in headers like custom headers, or just accept headers with a vendor? The V&D is the vendor specific type, where you just indicate as a client your request of consuming a particular version of the web API. You can also do the group versions, which is something that Microsoft uses in Azure. The group version is like a date, and it's a bundling of multiple versions across many web APIs. So you can just say, at this point in time, we had version 1.1, 1.2, 2.0, and that together is a certain date, so timestamp. If you want to put that into your web API, it's not really difficult. You use some attributes on top of your classes, on top of your methods, if you will, and that you take it from there. And you only have to decide, do I split up the separate versions, or are they so close to each other that I can actually maintain the controller classes, which is where the API service occurs. Do I keep them together because all of the logic remains the same? It's just a matter of different serialization, or well, just close together. Or you could just separate them out. It's up to you. Namespaces might help you out there. So next demo. In the next demo, I put in a lot of stuff. So if you look at the solution now, there's actually quite a lot new. We have this client SDK integration tests, and the project itself is also, it has more plumbing, and we'll go through all of that in a bit. So let me see. First of all, some changes. I included a lot of new NuGet packages. At first now we will use this one, the ASP.NET MVC versioning. So that's one of the changes. We added that, and after that we can go to our controllers. I still have the old controller. I renamed the file to v1, put some attributes on top of the controller class, which says this is the API version 1.0. It might have been 0.9, but that one's deprecated. I included a new route. So the route indicates how you would reach it, and in this case it's inside of the path of your web API. So it says API/v1 or 2 or 1.0. You can use whatever you like. Since this is the old one, it also advertises that there's a newer one. So that's 2.0 is also available. So if you're consuming it, your headers will actually be able to indicate there's a newer version. And in the newer version, that's this one, it's in this other namespace, v2. It says it's 2.0, it has the route as well, and well, this is essentially enough to put the metadata in there, and then we can go to the startup. And in the startup, we have this configuring of versioning. So I put it all in the configure services, and here you just do this extension methods on the services collection, which says the default API version is 2.0, so if it's unspecified, assume that it's 2.0, and report the other API versions. So that's deprecated ones and the newer ones. Like we saw, 0.9 and 2.0 were advertised. This says you can actually report them in the headers. If you want to be more flexible about it, and you can use this Fluent API. I've commented it out, but you can also use this runtime way of applying versions to your implementation. It's whatever flexibility you need. Normally, the attributing is enough. So if you run this, oh, sorry, we got to stop the other one. There we go. Let's do that quickly again. So still the same implementation, but we have the V2 here. If we run this from something where you can actually see a little bit more, we can go to here. We can take this one, send it out. You can see that it has the payload in JSON now, so it's no longer plain text. We've done some formatting, and inside of the headers, we should be able to see that there's this API deprecated version and the supported versions that are in there. So now we have a version Web API. We can start building newer versions, and clients can choose whichever one they can consume. All right, next one. Okay, so we are calling an external resource. If you're doing cloud, in cloud things can be unavailable temporarily. Probably in your on-premise data center as well, but in the cloud it's more of a given because machines might be taken down and moved somewhere else, and it will all, in the end, it will all be fine again. But transient errors, like temporary errors, they occur and they will go away. So one of the things is to deal with them. And how would you do that? Usually it's retrying, but just retrying forever is usually not a good idea because you can actually block your system. If things come back, you can overload it. So you need to be careful about how you do it and think about your strategy there. In this case, you can do a lot of things because even your own systems can go down. But now we're focusing on external calls, assuming also that you have exception handling in place. But if you're calling external databases or web APIs like we are doing, if you're putting things in queues or buses or reading from it, those things can break. One of them, two of them, all of them, if you're unlucky. But you need to take into account that if you call something, it might not be there. There's all these cloud patterns that I recommend you look into if you don't know them yet, but retry is the most important one, I think, because if it fails and you know that it will be back afterwards, retrying is usually a really good thing. But you need to be careful there because, just like I said, retrying too fast, indefinitely, usually not good. So circuit breaker is where you essentially give up after a while. You can also give up after a certain amount of time. So just have a guard for a specific timeout. If you say it takes too long, I will just break it off, fall back to certain implementation. And if you want to make sure that you're not clogging another thing or isolating parts of your application from other things breaking down, it's the bulkhead. So those things, you need, but retry is the most important one. And a lot of the Azure resources, if you're using that, and Amazon, it's the same thing. You will actually find it in their client SDK. So to call the resources, you will have a lot of things where you can tweak the retry mechanism. So it's all in there. If you're still on, not on .NET Core, but on .NET Full Framework, you can look at the transient fault handling block, which also has a couple of patterns in there. You can do your own stuff inside of containers, which you usually do. Entity Framework has things built in. So from a lot of places, there's already retry available. And you should use that if you can. But in some cases, it's not available. So there's this library. Christian referred to it yesterday if you were in his talk. At the end, he said you can use Poly. And Poly is this open source project. with a lot of the patterns that you just saw implemented. And it's very easy to use. You define all these policies on how to deal with it. So essentially, it's strategies. And you can combine the patterns that we just saw and define if there are certain HTTP request exception, I want you to handle it, and this is the behavior you should do. So you should retry it. You should fall back if it fails after a number of times, and so on. So you can chain them together, and you will actually use the policy that you create from building this with this Fluent API and wrap it around a Lambda that you do, and that's your actual implementation. And it will get all of the resiliency patterns applied to it. In ASP.NET Core 2.1, Microsoft adopted the HTTP, the poly library as their go-to package for resiliency. And there's a new thing in there that's called the HTTP client factory, which allows you to configure how HTTP client objects are created. So if you have them injected into a constructor of your controller, for example, the HTTP client factory will be called, and you are allowed to configure your client with timeouts, base addresses, headers. But on top of it, you can actually apply poly. So the policies that you have can be put on top of the HTTP client. And we need that because when we are calling the external Web API, under the covers, the refit library is using an HTTP client. So in this case, poly will have all of the policies defined. HTTP client factory will create the client and wrap it with the policies that you created. And then you can inject it into your controller and just use it fairly easily. So let's see that in another demo. Okay. So another demo, then we go to the startup again. We go to typed clients. And I want you to focus on this bit first, this part. This is what the bare HTTP client factory does. It allows you to define a named client. In this case, we're calling the Steam server, so I called it Steam, but it's just a symbolic name. And you can add several options for base address, timeout, and headers. So each time you ask for an HTTP client Steam, you will get this configuration. This here is where you can create typed clients. And a typed client is an object that is constructed with an HTTP client injected into it. But it's another type of class. And you might recognize that we're actually reusing the refit library, but we're passing the client that is being created in this Lambda, we're passing it down into the refit factory, where something will come out, and it should be, this thing will actually return the client builder, but this method here will return an iSteam client. So we're still getting a Steam client, but it's with a configured HTTP client. And on top of it, by using this add policy, we can say, I want you to use a timeout policy. And if you're running over 1.5 seconds, just quit it, regardless of any 15-second timeouts that might be available somewhere else. You're taking control of it. And in this case, we're also doing a retry 3 times. It can be much more complicated. You can construct all these lambdas and take care of what happens if we retry, what if we give up at the end. You have all these interception points where you can add additional code. But this is just the basic one. We're retrying on transient HTTP errors. That's there if you have 500 and 408, 422 errors. Those are errors that indicate that we can recover from them. So with this, a new client will be created. And if we go to our controller again, and look here, we're still running, so we should be able to press F5 here. You can see that the client that's being injected here, let me zoom in a little bit. This client is actually an auto-generated iSteam client. So it has all the stuff in there, including the retry mechanism. And calling it from your controller class will actually be like before. We just call it, but it has all the behavior applied. you need to do a bit of try-catch logic, because if there's HTTP request exception, that will still bubble up. If you have the timeout, as in your policy, you get timeout rejection exceptions. You need to handle those as well. And if all else fails, if something else happens, you need to catch that as well. So you can do the applicable status codes like 504s, 502, whichever is indication of what actually went wrong and where can the caller do something about it. Make sense? Yeah, good. Okay. So that was actually what we did, unreliable connections, client factories, and refit. So moving on to documentation. You might have heard of Swagger. Swagger is a tool set to build up documentation, much like for the SOAP service you had the WSDL files. There's still this need for your Web API to be described in a technical sense for machine consumption and for generation of code and so on. Swagger moved on and they split out the tooling part, which is still Swagger, and the contract definition part, which is now called OpenAPI. It's at version 2.0. We're moving into 3.0. And your OpenAPI contract is it has a service contract, a message contract, a data contract, and even a fault contract of things that can go wrong. This is good if you want to reach out to other consumers and describe your Web API. The Swagger tooling, there's a bunch of it. There's the Swagger editor. You can go online, use the online editor. There's even tooling that people build around this Swagger. You can decide if you want to go contract first, so define your OpenAPI contract and then generate the service stop from it, or you can go the way I'll be showing it, from your code, do metadata and generate the Swagger or the OpenAPI documentation from it. There's all these libraries. Swashbuckle is a very popular one, but Microsoft is also heavily investing into NSwag, and they're choosing that as one of their favorites. So I chose to do NSwag for this demo, and you can see that. And there's a lot of documentation on both of them. QSwag is another one. There's more. I didn't list them all, but you can just pick whatever tickles your fancy. Essentially, what you need to do if you go from code first to your contract is that you will decorate your Web API with more metadata, just signifying of what is it that my Web API does, what does it produce, which status codes, if it's a 200, what will I return. There's the action result of T, which allows for better inspection and predictability of what is actually coming out of your functions, your actions. So if you have an action result of string, it's probably a string coming out of there. If it's a complex type, a structure, that can be deduced from it as well. It respects your data contract, so all the validation attributes that might be there. It can do for the API controllers the content type that you'll be producing. And also you can do more metadata in XML documentation, but you will have to flip the switch in your project properties that says generate me the XML documentation. And if you copy that into your run folder, it will actually be able to pick up the XML file and do more stuff with it. Another demo. So what does it take to build out the documentation? Let's see. So going to our controller again, it has the attributes that were in the slide. So in this case, if we're producing a 200, I'll give back a list of game server info objects. We also produce a 400 in some cases, and that's essentially it for that part. Here is the produces. I'm telling it that I'm producing either XML or JSON, so you can do content type negotiation, which is also a REST thing. And then we go to the startup, because usually it's split in two places. In the startup again, if we go to configure OpenAPI, the first part is kind of easy. It's just add Swagger. You add everything that is needed. And this is particular for NSwag. If Swashbuckle, if you're using that, it might contain a bit more. But the second part is actually where you define your own pipeline. And it's you need something like this. So the Swagger UI will be going to the UI in a bit. Is the generated helper API pages where you can exercise your web API. You'll need a route for the JSON that's produced. You can tell it how the editor. I clicked that. So how it will behave, and you can have some generator settings that has some descriptions, and that is also more descriptive. Because we have two versions. We actually need this twice, and you can configure them separately if you want to, so the versions will probably differ. If you split them across separate solutions, you'll have just one of these in each of them. But now they're combined. But if you do that, you'll find that because you have both of the implementations in the same project, the same solution, they will actually show up. So if you have the V2 version, both the versions will show up, unless you do this filtering on to include only a single version inside of the description of your web API. So let's see if we can go here. Normally, if you go to the Swagger endpoint, just /Swagger, it will redirect you to this user interface that's being built dynamically. It's kind of simple now because we only have one method, but it's enough to prove the point. You can actually go here. You can see that there's 200 responses. You can see what we will actually get returned. You can specify the limit here. I didn't include the API key because that's hidden underneath. And you can even try it out, and you see it will just go to your implementation. It will return. And then under here, you'll get the request headers that we send. And this is the response body and the response headers, where we still have the all the stuff that we did before. So this is a way that you can exercise it. I've put that behind a... so only if it's in development, that's up to you. If you want to also provide this UI in production. But, well, trade-off, if you want to expose that or not. Yep. OK, now that we have the documentation in place, we have versions. If we want to change implementation, and we want to know, do we break our contract? And there's this thing that you can do. First of all, provide a SDK, so a software development kit for your clients. It's not necessary, but it's a convenience thing. Having a client SDK makes it easier for your consumers to exercise your API, and you can go shallow, so like a minimal implementation, or like all out with retry patterns, just like they do in the Azure SDKs. With the OpenAPI documentation, you can generate most of what you need because it's a very predictable way of calling your web API. A couple of things that you can do. We talked about the refit on the far right, because that's, if you don't have any documentation, you can still use that. You need to do some tinkering on how to get the interface right. But once you have it in place, it will work. But with OpenAPI, there's a bunch of tools, and I've listed AutoRest and NSwag, where you can generate most of it. AutoRest is used by Microsoft for all of their Azure SDKs. And it's a really rich, extensible library. NSwag has also something like NSwag Studio to generate clients from even compiled assemblies. But there's an abundance of choice. If you have that, if you have the SDK, it will make it easier for others, but also yourself, to call your web API. And you can use it in your advantage, because if you have, for a particular version of your web API, you created your client SDK, they are in sync. And if you start changing your web API, you can use your own client SDK of that version to see if it still works. And if calling it from your web API, from your client SDK to the web API, and if it starts returning errors, you know that you broke your contract. So it's like a way to test in your build pipelines, did I do bad, or should I start changing version numbers again? We'll go into the details of how that's done in a bit, because there's a lot of stuff that will help you out doing that. So first of all, let me stop this for a second. So the document itself, for version 2 looks something like this. So you have the paths of all your web APIs, your controller classes essentially, with the documentation that we generated. So this is all produced, and you have your models. So this is the game server info object, and it has a couple of properties, and the properties are just listed with their types. So this is the web API documentation. And if you go to your command line, autorest is a command line tool. If you run it, and I need to get that from, it's a long, complicated one, so I'll just take it from here. So if you run it, it will essentially load up a couple of stuff for the type of client that you want to generate. In this case, it's C#. We'll look at all the stuff that is there, and if all works out, we should have this new directory here, SDK live, and I can do a directory on it. And you see that it generates a couple of stuff. So this is the overall proxy, and for each of your controllers you will get this interface and an implementation and some extension methods that allow you to call it more conveniently, like just get, whereas this one has all these complicated methods that allow you to more directly interact with it. We'll see that in a bit. If you want to automate this, it's quite doable. So you can do a PowerShell script where you just download the version that you want to have. I already did, but this is where you, at one point in time, download the documentation, run the autorest. You can use the .NET to create a new solution, a new class library, add a class library to the solution, delete the templated stuff, add some packages like the REST client runtime, which is what the autorest requires, some JSON, ASP.NET Core, build it, pack it, and you have a NuGet package containing the client SDK. And that has the classes that allow you to call your web API. In some testing scenario, so the contract integration tests, you would go about like this. So first of all, in your initialize, you would start creating a test server. And to use this test server, you need a NuGet package. And the NuGet package is called ASP.NET Core test host. So in test host, you'll find this test server. Test server creates a web server, locally hosted, in memory, and it will create an HTTP client configured to call the test server. Excuse me. And the test server, the HTTP client will call the test server without any network overhead. We will then take this HTTP client and put it inside of our proxy. So we use this pre-configured HTTP client to start calling our own web API. The way this is built, this test server, it needs all the plumbing that we had. So I also added a reference to our project. So in this case, I also included the client SDK, but you might want to do a NuGet package there. And the web API is our own implementation that we're testing now. We're telling it that we're using the development environment or production, whichever you prefer, and then we do use the startup. But it's the startup from our web API implementation, and it injects all of the stuff, including our refit HTTP client that we constructed there, but that will make the actual call. And in the test host NuGet package, there's also this extension method on the web host builder called configure test services. And here we actually override the iSteam client with a mocksteam client. And a mocksteam client is just as an implementation where we return whatever you put in as a limit, return as much of the server info objects as a result in the format that is expected by a call to that external web API. So we're stubbing it out, we're creating a mock. Then with that in place, we all of a sudden, we can use the HTTP client here to call to see if our Swagger documentation is available, because that might be a test that you can do, ensure that it's successful, and you can call your own web API with or without query strings. So here we can use the proxy, with the game server. This is all the auto-res generated stuff. And here you can see that there's a bunch of methods, like the get with HTTP messages async, that's a bit raw, and the convenience extension methods, get async, which allows you just to call it with or without the query string, because here is the same call with a query string, and you can exercise your web API. And it's hosted inside of the unit test. So if you run it from here, I don't have anything running. If all goes well, we should see them pop up, and they should all turn green. Oh, this happens sometimes, and we need to do a rebuild. If you start, this is Visual Studio 15.6. If you use that one and you start up an ASP.NET Core 2.1 Preview 2, it actually suggests you to move to 15.7 Preview. I think this is one of the small things, because now it rebuilds. I think Visual Studio gets a little bit confused there, but it will be fixed in 15.7. It's not really looking there, so we've got all green, and we know that if we change stuff, this will tell us if we broke the contract or not. All right, moving on. Wait, I didn't show you one test. It's the raw one. If you use the method like get with HTTP messages async, you can drill down into the individual status codes and read your own content from the response body. So it's just a matter of which level of abstraction do you want to run your test. Okay. Then, so now we know when we need to version, we can use the documentation to generate the clients. It's all good. But if you want to move to production, you should know how your web API is behaving in production. And from experience, we've gone to customers, and they have runtime issues, production problems, and you ask them to give me some telemetry, give me some logging, and they're like, no, that's not really there. So this looks kind of good. All the instrumentation is there, because nobody wants to fly in the blind. If you know it's running, it's behaving badly, but we have nothing to go by, we can't debug it, we can't tell anything about it, that's not the place you want to be. So for your individual applications, you need to know, how is my web API doing? Is it still healthy? Because I want to take actions if it's degrading. I need metrics so I can tell whether the performance is still okay. And if things go bad, I want to be able to trace my calls from to exception places from all the way where it started. Just in general, how is it doing? But also across your landscape, you want to do that, because just an individual API is one thing, but we are calling another API, and we might be calling into databases. And so your entire landscape of implementation hosted somewhere, you want telemetry on that. So you can actually see what is calling what and where bottlenecks might be or where issues might occur. There's, again, choice. It's up to you what you want to use. New Relic, App Metrics, there's all these paid and unpaid services. I'm demonstrating App Insights, which is the Microsoft Azure version, and they provide a fairly easy way to get all of this in place without having to do much. In the end, if you have all this in place, you will see that you get really rich telemetry and information about your web API. Where do things go wrong? What about call times? And you can, all these facilities to make it easier for you to find out what is going on. Talking about health is pretty common, where you can ask your web API, how are you doing? It's usually located at a /health, which gives you a status, unknown, healthy, unhealthy, or somewhere in between. And you can define yourself what type of health checks you want to have in your implementation. So in this case, in this code snippet there's health checks that will actually do a call to an endpoint and see if it's alive. So if something comes back and it's an expected result, you'll say, okay, so the URL check went well. And you can do other checks like, is the database connection able to make a connection? What about memory pressure or statistics of my system? It depends on the library that you're using. I'll be showcasing the Microsoft implementation, not the one listed there as a NuGet package. That's the one that is coming, but it doesn't have specifics like the URL check or the database checks. I'm using one that is listed in the source code, and it can do those kind of things. Once you have the health checks in place and you can ask at a particular point on your Web API, how are you doing? You can also use the instrumentation and the monitoring solution to find out when it flips from healthy to unhealthy. And then you can raise alerts and page people, send them text messages, whatever is needed to get attention because something is going bad. Also a bit about logging, because I think that most of you have done your fair share of logging and put it in places. One thing that is less known is structured logging or semantic logging. It's supported in ASENET Core, not by every logging sync, so you need either Serilog or application insights, and there might be a few more, but those two work. And the idea is that instead of just concatenating a string by string interpolation with the $sign or string format. You can do that, but it's just a plain string. And if you want to extract information from it, like the search limit that we did for our Web API call, you need to parse it and you need to know the exact format. So you need to build regular expressions, and one programmer or the other might do it a bit differently across servers. But in this case, you can see that it says searching with, and then it's this template thing, search limit, and it has a parameter at the end. And it's not a 0, it's just this symbolic name, and it's positionally matched. So the names don't have to match. If you have this in place, the message template will be stored, it will be concatenated to one string, and you will have individual parameters that you can query on. We'll see that in a bit. But if you do your logging, make sure you get your logging levels right. In Moscow, so DotNext Moscow, half a year ago, Dylan Beatty did a talk where he actually mentioned all of the levels that are there, and like critical is like people get called from their beds, but you might want to step down and go a bit softer if it's not that critical. So choose your levels wisely, and don't choose them because you want to say this needs to go to this particular log sync, like this needs to go in the event log. You shouldn't decide on that because your providers will just be registered, they will have their own filters on levels. And it should not be, you shouldn't take it into account when you are actually writing to the log. There's some tips and tweaks. If you need to do high performance logging, you can actually do the event source one, that is ETW, that's event tracing for Windows. That's really low level, low latency. But still, if you start logging, you allocate all these objects. There's log message.define, which is a lesser known way of doing it. But I'll show that in the code in a bit. And you can even apply filters per category. And final thing on the logging is if you do logging across your entire landscape, do keep in mind that each host of a Web API has its own log locally, probably, but you want to centralize it to span across your entire landscape. You can do things like log indexers, Splunk, the Elk stack, or you can just leverage all of the things that are available from your hosting platform. So application logs, but that's usually local, not aggregated across all of your landscape. All right. So let's start with health first. Here we go. So we go to startup again. Oh, we'll go to program. I took apart the create default builder. Inside, essentially, there's this piece of code. So a lot of things are being registered there. Do have a look because there's these special things for validation that's only on in development. You might run into that. But in this case, I added this one. So I'm telling it to use health checks at this endpoint /health, and that's intercepted by the middleware, and it sends it out to provide the health information. And to implement that health information, Like I said, I didn't use the preview NuGet packages, but just these two that are available. It's in a different Git repo by Microsoft. I put in the source code and compiled it, but this has essentially the same things as the NuGet package that will be official, but it has things like the URL checks, numeric checks, and system checks for memory. So we're using this. And you can do that in your startup, because if you go to this part here, you can do add health checks and define a lambda that says these are my checks. So I'm adding a URL check, and in this case I'm pinging the HTTP endpoint, but in this case 200 will not be returned. It will, if you just go to the base URL, it will give you a status code of not found. But it means it's there, so it will probably work. In this case, I'm telling it, okay, if you get a 404, you're considered healthy. So that's one part of it. Then for the logging, if you go to the controller, the simple logging is something like this. Log, warning, and you just put some exception there, or just a message, or a combination of both. This will be sent to whatever you configured in your the creation of your logger factory. So I'm adding a lot of things here, like application insights to do it in a central place. Azure Web App Diagnostics will tie into the hosting of the Azure App Service, and some things for debugging and ETW. Just to show you that all of these places, it's you write one warning, but it goes to all of these places. Then for the structured logging, structured logging will look something like this. So we have this search limit here, and we just put in the limit. If you want to do the log message.define, I'll quickly show that. I created this extension method on the iLogger interface. It's a pattern that Microsoft uses. This game server list requested is an action delegate that you can construct with the log message.define. And it's just a static delegate that takes a lot of the information. So here's again our template, where the things that you inject, in this case an integer, will be put into this place. So with all that, yeah, we should have a look. I added instrumentation with application insights. Each of the solutions that you might use has a different way of bootstrapping it. In this case, all I need to do is add application insights telemetry, and I'm putting it into developer mode if the environment is development. So I get an immediate flush of all the log messages that go out and the instrumentation information. There's this instrumentation key that I'm getting from my configuration that instructs it, so where should it go inside of Azure. Yep, that's about it. And we should have a look. So let's go to the Web API. I can increase this a little bit. So if you're hosting somewhere and this is hosted, this is the Web API hosted, this is the application insights, it's connected together, so it's actually running in production as we speak. And if you go there, you can see that there's one server online, that's the online server. If I now go and run this, and we put that on, so there we go. We should see that there's 2 servers online in a second. So see, now it's 2 servers online, and we get this telemetry here. Let me make it a little bit smaller. And if we just press this a couple of times, maybe do a bad URL. Yep. Then you'll see this, all this information coming in. This is what you want if you want to run in production, because now you can actually tell what is my Web API doing. You can see the errors coming along, and you can start querying. So if something goes bad, in this case, you could also go to availability. how were we doing? This is using the health endpoint. Let me quickly show you that, because is it still healthy? In this case, we're doing the local one, but it says it's healthy, so that should be good. The same goes for production, and you can see that all of these pings that were done on the health says it's good. If it's not good, you will get start alerts to you. And you can also go for, let me see. So if you go to the live sorry, just a second. I need to, well, I'll show you the application map, by the way. This is where you automatically get a plot of your entire landscape, what is calling it. It's so simple now that it's just our web API here calling the external resource, and this is the availability. If you have client applications like mobile applications, they will appear. If you write into blob storage or any other Azure storage or resource like an Azure SQL database, it will appear there as well. And now let's see, if we go to overview, we can go analytics. And in your analytics, if we take a new query, you can query all of these things here. I'll quickly show you. So maybe something went wrong if we're having search limits over 20. So in this case, in this thing here, I'm using the structured logging. Remember the search limit that we had? This is the term that was inside of the curlies. You can run this, and it will, you can run this, and you will actually see the full message with 100 results. But inside of this, this metadata, you can also see that the original message is still there with search limits. And search limit is also metadata that you can query on, because this is where we actually did a query. And this will work if you aggregate from a lot of sources. So, coming up to the end of the session, moving into production. There's still this notion of having multiple environments, and you can have them for testing purposes, for example. But a popular one that is actually occurring is considering everything production. Whatever you do, whichever you choose, make sure you have something in front of your web API. You can expose it, but you shouldn't expose Kestrel out in the public. And also, if you have consumers of your web API, you want to do some client checks, so who is calling me, regardless of your security model. And you want to be able to throttle, if necessary, revoke API keys that you hand out. And you need something like an API gateway for that. Also, if you want to make money out of your web API, that's also a good thing to place in front of your web APIs and aggregate them to a single endpoint. There's this thing that Microsoft is working on, ASENET Core proxy, that allows you to build a proxy inside of an ASENET hosted application. So that's something that you might want to have a look at. But if you consider everything production, then you can just quickly deploy to production, and you can even put new stuff in production without it being tested very well, because the idea is that with a traffic manager or an API gateway or the combination, you can have your original API and the API with the new functionality. And you can use feature toggles to toggle on and off the new implementation that you have. We have 2-3 minutes to do that. So you can choose your library. I've chosen this library called feature toggle. And essentially what you do is you define a class or more with that is derived from a particular type of toggle. So this is the simple feature toggle that introduces advanced health. It's a class. It will be constructed out of your app settings. And in your app settings, you should have something that names that particular one, and it says is it on or off. And with that toggle, so you can switch it on and off, all you need to do is in a place where you want to do it, you need to say, if this feature is enabled, and the feature in this case is the advanced health feature, I want to add additional health checks. And with that, you can release it to production. It's there, you don't have it on. You can switch it on and start monitoring your system. Will memory go through the roof? Because that's a bad sign. Will things start breaking down? And you can quickly switch it back. And because you're splitting your traffic between the original with the feature off and the new feature on, you're directing a small bit of traffic there and a lot of traffic to the old one. You can try it out. If it's bad, switch it off, fix it, roll it out into production, and once you're confident, you can do more traffic to the other side until the other thing goes away. You might have noticed that I also had these always off, always on. If you want to know what that's about, you should come to the discussion zone and I'll explain about that. So, that's the feature toggles. There's more to be said on security. We don't have time for that now, but there's this HTTPS that's now available. You can create your certificates on your local machine. I've been using HTTPS all through this demo. It works out of the box. HSTS is also an interesting feature. That will be in the discussion zone. And also, you need to hide your secrets because the API key that you all saw, you want to put that into a secure place. So, skipping over most of that. So, at the end of the talk, I took you through a quick journey from file new project to documentation, to monitoring, instrumentation, health, versioning, logging, and a lot of other things. Take that into account if you're building your new web APIs. Make them robust and production ready. And I'll be seeing you for questions in the discussion zone. Thank you very much.
Thank you, Alex.